So, a really important part of your cerebral cortex is something known as an association area. You have many association areas, they're scattered all over your cortex, and they are defined first by what they're not. Association areas are not areas of the brain responsible for taking in direct sensory input or for producing direct motor output. Instead, your association areas are going to handle the integration of all of that type of information together, and they accomplish higher processing. Some more specific examples of the types of higher processing that your association areas do. They're going to link incoming sensory input with stored memories. And this doesn't just mean sort of higher level personal memories. It means that when you look around a room and you identify things as colors or as specific objects or faces, you're able to accomplish that type of recognition based on the work of your association areas. You learn information, you have insights about information, you remember things, you process and analyze, you're able to speak in complex ways, all because of this work that's done inside your association areas. Where are your association areas? Well, here there's just a simple diagram of the brain with a couple of different items labeled. But what I want you to pay attention to are the areas labeled here. We have auditory association area, and then visual association area, somatosensory association area, frontal association area. Pretty much the parts of your brain that are not specifically devoted to motor or sensory cortex are fair game for association areas. So they surround those primary input locations. What do they do? Well, depending on the lobe that they're in, they can do different things. You have association areas in your frontal lobes, which are responsible for judgment, planning, processing new memories, for personality. If you remember back to the case study of Phineas Gage, we recall that it was his frontal association areas which were impacted, and so his personality drastically shifted. Second, we have the parietal association areas. These generally are responsible for mathematical and spatial reasoning. I'm kind of giving you a stereotypical example, but there are other functions that you can find in these different areas. And what I thought was really interesting is we think of Einstein as being someone who is just so awesome at math and at like higher level mathematical processing. Well, in his parietal lobe, actually, he had sort of an abnormality. He was missing a section, which meant his parietal lobe actually was able to expand, and parietal association areas enable math and spatial reasoning. So that's either an outcome of his use, or maybe it allowed him to use them in that way in the first place. Temporal association areas, a bunch of different things. One of the coolest ones is that they enable facial recognition. You will learn later about something called prosopagnosia or face blindness. People who they can see faces, they just can't recognize them as distinct from each other because their what's called the fusiform gyrus, or their temporal association area for facial recognition, isn't functioning correctly. And then lastly, occipital association areas, they handle really complex visual processing. They do a lot of work because there are a lot of things we see in our environment that we have to be able to recognize. Overall, your association areas are super important, but when directly stimulated, they don't actually produce anything. And so we think that this is why sometimes people are under this false belief that you only use 10% of your brain. That's not true. You have different association areas responsible for really crucial things all over your brain, but since when directly stimulated they don't do anything, we think that's where that myth sort of started.